afternoon and Jai Hind to all. I Neeraj Sharma, Assistant Professor EC Department at Ajay Kumar Garg Engineering College, Ghaziabad. So I am before you to present the video lecture for the complex topic series for the subject Microwave and Radar Engineering, whose code is as per the AKTU syllabus, that is the KEC 074. So in this lecture, I have topic which I am going to cover from the unit 5th of the this subject, radar. So here the topic which I have selected, that is the unambiguous range and the Doppler effect. These two are the very important topics or the content as per the radar theory, because this is the one of the more important device right now which is going to use for the air traffic or to the surveillance and as well as the navigation system or the military purpose. So that's why we can able to identify what the object is coming, what the object after the some distance. So that we can identify. So this is the main working of radar, which is simply define the ranging and detection of the RF signals. Now, so in this, what is this unambiguous range? So we have to focus on this one. So in simple radar system, echoes from targets must detected and processed before the next pulse is generated if range ambiguity is to be avoided. Basically, what will be happen in the radar theory, we see that when from the transmitter a signal is transmitted in the direction, and after that transmission for after certain interval of time, this signal will reach to the some distance. Let's say it will be the distance will be r, and let's say some target will be there. So what this signal will interact with this target, and its properties will now get sent, and it will revert back the echoes, and the receivers and at receiver section for the transmitted signal, the receiver will detect this echoes, and at the presence of echo, it will identify that there will be some object at the particular distance r will be there. So here, so that means we are simply sending the time signals and wait for the before transmission of the next signal. What we are doing, we have to provide some specific time duration. So that's why the signal can be echoes can be detected. So that after that we will send the other one. If it is not that, there will be some ambiguity will be arises. So here it will state that in simple radar system, echoes from the target must be detected and processed before the next transmitter pulse. Okay, first we have transmitted, then we will wait for some time, and after get the echo and processed onto that what the information we want to get, so we will get, and after that then we will transmit the next pulse. So this ambiguity condition can be avoided, but this range ambiguity occurs if it is occurs. So what will be the condition? If it will occur, it is also a possibility that we can neglect it. But if it is happened, it's something like will be error. So what we can do some correction in that, so that we can get. So here this range ambiguity occurs when the time taken for an echo to return from a target is greater than the pulse repetition period echoes that arrives after the transmission of next pulse are called as the second time around echoes. So what will happen actually, if we will see this like this one, let's say some pulse now we have transmitted. Okay. Like this one. So here this will be the signal. Let's say we have now transmitted. Okay. So this will be the transmitted pulse. This one, let's say next transmitted pulse. and this is simple geometry, and here this will be the t on time, this will be the t off time. So the total time for this pulse, if we will say this will be the on period, this will be the off period, this will be the now complete total time TR. So which will equals to this TR, we can also write it like this, T on plus T off. So what will happen here? First we have now transmitted this pulse. So what we will do? This transmitter section has been transmitted, but this pulse we have transmitted now, and so what we will system will process that it will wait for some echoes. That means some response at the transmit receiver will get for this transmitted pulse for a certain interval we can already define. Longest duration we will define. So in that duration, the longest duration means this means the distance. How much distance it will covering. So it will echoes will be now revert back. So what will happen here? So receiver wants that we will get some output for this transmitted pulse here, but it will not able to detect. So but after a certain interval of time, after this TR duration, this complete where it will include the addition of T on plus T off period. So after this certain interval, before getting any output for this transmitted pulse or echoes get for this transmitted pulse, next pulse will be transmitted. But suddenly what will happen after transmitting the next pulse? This echoes will now revert back. So this will be the second time around echo. Okay, so for the transmission, first transmitted pulse, we want some echo, it will not get. So what will happen? The next pulse, the transmitter will send after a certain interval of time, then it will receive some echoes that will known after the transmission of this next pulse. So it will known as the second time around echoes. So here there will be some ambiguity into that the receiver station. What will be the actually output? This output have come for the which one? The first one or the second one? So their ambiguity will be comes into the picture, and the range for this beyond which the radar can detect this second time around echoes, it will simply the unambiguous range. So here echoes received after an interval exceeding the pulse repetition period, that means the second pulse what we are transmitting, are called as the multiple time around echoes, and these can result in erroneous range measurement. So that means there will be some issues with it. So the range here, the range beyond which target appear as second time around echoes, this one is called the maximum unambiguous range, and it is will denoted by R unambiguous by this symbol. So we can now able to calculate or able to identify what will be the value, because target is appearing after the second time around echoes. So this will be the ambiguity. There will be some confusion in the mind that what will be the our exact. This will be the response for the which one transmitted pulse for this one or this one. So in this case, the second time range beyond which the target appears as the second time around echo is called the maximum unambiguous range, and this maximum unambiguous range is given by RU is equals to, or sometimes it is the maximum value of distance, or it is the unambiguous range is equals to the C into T by 2. By this formula it can be given by, or we can also write it like this: C into maximum value of this TR divided by 2, or we can now put this value into this formula of this TR value T1 plus T off. So it will become R unambiguous range is equals to C into T on plus TF by 2, or we can also write it that C is equals to 2 into PRF. This will be the PRF is nothing but the pulse repetition frequency for which this echoes will get. Second time around echoes will be get. Okay. So this is the unambiguous range. So this is one of the important topic for the radar theory as well as for the we will discuss for the exam point of view. Okay, so for past 2 years, one numerical we can also demonstrate how we can calculate for any numerical data if it is given. So at the last year, this one numerical problem has been had been asked in the AKGEC examination. So I have also considered. I have also taken this numerical problem for practice point of view how we can calculate if we will get. So that it can be also helpful for some competitive exams as well. So here the question has been comes that a typical a typical pulse radar waveform has the T on duration that is the 10 microsecond. That will be the T on is equals to 10 microsecond or 10 into 10 raised to minus 6 second. After that, it will having the pulse repetition period TR is equals to and power gain is given also here this 10 milliwatt. So the question has been asked that what will be the duty cycle and the maximum radar range, maximum unambiguous range here. So the first part, that is the duty cycle. Duty cycle is simply the ratio of the T on over total time period, means for the pulse which duration pulse is on divided by the total time, that means on period plus the off period. So T on plus T off, or it will equals to the TR. So here it is the 10 into 10 raised to power minus 6 and this one is 10 raised to power minus 3. So duty cycle will comes out 10 raised to power of minus 3, or it will be 0.001 here. So we can now calculate this one in this way. After that, the second point, maximum unambiguous range. It is what its value. Unambiguous range means R is equals to it is given by C into TR by 2. C is the speed of light, that is 3 into 10 raised to power 8 meter per second, and the value for this what we can say TR, that is the 10 millisecond divided by 2. So after calculating this value, the range will be coming out around 1500 meter. So in this way, for the any given data, we can able to, by this formulas and the procedure, we can able to calculate the value of this duty cycle, unambiguous, as well as sometimes the average power can be also asked. So average power, P average, is equals to simply the power gain multiply with the duty cycle. So simply power gain is we have this value, this 10 milliwatt, and the duty cycle is what we have the value of this duty cycle is 0.001, so we can easily calculate. So in this way we can also solve the any numerical problem which can be asked for the unambiguous range. So next one topic, that is the Doppler radar, which will be based on to the concept of Doppler effect. So in this Doppler effect, what will happen actually, radar radiates some EM waves toward the target for detection and also to obtain the details of the target. Means transmitted any pulse and some echoes will be revert back. If the target is stationary, then the frequency of the received echoes is constant. Okay. When the target, at this time there is no problem. Let's say some point at the mountains winds and some other rocks will comes out, so that it can be easily detected. But the problem will comes when we have to go for the some practical situation like military application or the some air traffic problems. So where the movement planes are moving constantly. So in this way, what will be the exact position? Because at this time the target is continuously moving. It is not fixed. So in this way, how we can able to detect the exact position of the echoes? So when the target is moving, the frequency of the received echoes is found to be different from the transmitter frequency. Means the frequency will be changed now. If the target approaches the radar, the frequency is increased. Means coming, it is simple radar station. If target is coming like this, so the frequency will be increased. If the target moving away like this, so the frequency will be decrease. So that is a moving target. There exists a frequency shift in the received echoes. If we will able to calculate the received echoes received frequency shift, we will able to calculate, so that then we can able to find the exact position of the target. So the presence of the frequency shift in the received echo signal in the radar due to the moving target is known as the Doppler effect. Means the frequency change which come out for the transmitted frequency and whether as the received frequency, this will be named as a Doppler effect, or the shift is known as the Doppler frequency shift, and the corresponding frequency for this moving target is known as the Doppler frequency, which is given by the symbol F into F suffix of T, FD. So this will be the main concept of the to find the detector, to find the position of the moving target. That will be the Doppler effect. So on that basis, on the study of this FD analysis or the processing of this FD, we can able to find the exact situation of the moving target here. So if the target is in motion and the distance, let's say r and phi are continuously changing. So a change in phi with respect to time is equal to a frequency. This is the Doppler angular frequency, which is given by the symbol omega d, and it is now how we will find out this. So omega d is equals to 2 pi fd, or we can also define it by d phi by dt, and the value of this phi, if we see, the value of this phi is equals to 4 pi into r by lambda. So we can now put this value here. So it will become omega d is equals to d 4 pi r by lambda into dt, or we can also write it like this, 4 pi lambda into dr by dt here. So when we will put this, so this dr by dt is equals to nothing but the rate of change of distance with respect to the time, that is nothing but the velocity. Simple. Okay, so this will be the relative velocity we can define. Okay, so this omega d will become what? 2 into Vr by lambda. Okay, so 4 pi, sorry, this one, when put this value dr by dt is equals to VR. So it will become 4 pi into VR by lambda here. So the frequency value FD is equals to 2 into VR by lambda. So this will be the Doppler frequency for the any moving target. So in this way we can find out the we can now find out the value of this velocity in this way with the help of the Doppler frequency. So the relative velocity here now is given by VR is equals to V into cos theta. Okay, so here once this FD is what? This FD is the Doppler frequency shift in hertz, and VR is the relative velocity of target radar. Okay, then lambda is the wavelength here. So in this way now we can able to calculate this value. So this is Doppler frequency, relative velocity, just simply and lambda is the wavelength. So the relative velocity is given by VR is equals to V into cos theta. So if where V in this formula, the V and this cos theta, what will be signifies that, so where V, this is the target speed and theta is the angle made by the target trajectory and the line joining the radar and the target, because actual position of any moving target we will get when we have its actual trajectory. That means how much angle, if we angle variation we can able to find out, then the radar's actual distance we will able to calculate, or at the radar's actual position we will able to calculate. So in this way this formula FD is equals to 2 into VR by lambda. So it will now becomes change after putting the value of this VR is equals to this V cos theta into the previous of this formula 2 VR by lambda. So FD will become 2 into V cos theta by lambda here. So this will be the after getting the certain positions, if we will able to get the certain positions for any targets, moving target, if we have, then we can find out the exact value. So where if there are two certain position, at which time this FD will be maximum, at which time will be the minimum. So if this theta will be 0, if we will put this theta is equals to 0, so what will happen here when theta is equals to 0? So the cos 0 in this case FD is equals to 2 into V cos 0 by lambda. Cos 0 is 1, so FD is equals to 2V by lambda. That means in that condition this will be the maximum frequency shift change when this theta will be 0. If the Doppler frequency will be 90 degree, because theta will vary from 0 to 90 in the case of cos. So when theta will be 90, in case if we are using this theta is equals to 90 degree, this one, so what will happen? 2V cos 90 by lambda, we will get this value. So what will be cos 90 will 0, so it will become 0. So this means the Doppler frequency is now 0 in this case. So when the trajectory, condition will comes when the trajectory is perpendicular to the radar line of sight. That means like if this one is the radar and this one position, so 90 degree angle will be, so at this condition the Doppler frequency will be 0 here. So in the advancement of the radar to this concept of Doppler shift, we are now is come into the existence. So on the basis of that, continuous wave radar, FMCW radar, and the MTA radar will be deployed, and they are going to be used for the finding the exact position of the moving targets. So this is the now from my side for the two about the previously discussed two listed topics, unambiguous range and the Doppler effect and the Doppler shift frequency. Thank you and Jai Hind.